Welcome back to another episode of Math Cafe Enough Pie for Two. And sadly, still no pie.
Not unless you like 3.14.
Lame.
So today, we are going to be learning about central and inscribed angles and the relationship between them.
Perfect. So today you're going to need the worksheet, a protractor again, and a pencil.
No ruler this time.
All right, let's get started.
Have fun! Take out the handout with your circle and center labeled O.
All right, like this.
Now in that circle, choose 2 points on the circumference and label them A and B.
Okay. So I'll make this point A, and I'll choose point B right here.
Join with a line, A to O.
Okay, so I'm going to join it from point A to the center, O,
And then B to O.
and from B, O.
Now
Okay.
measure the angle AOB and record the measurement on your worksheet.
So we're measuring the angle from A to O to B. Alright. And it looks like this is about 70 degrees.
Alright,
Okay.
that you have created is called a central angle.
Okay, so angle AOB is called a central angle. Vocabulary. Okay, so we have a new word here, a central angle. So what is a central angle?
A central angle is where the 2 points on the circumference of the circle meet at their vertex in the center of the circle.
Okay, so it's an angle formed then by 2 points on the circumference and the vertex in the center. Well, that makes sense.
Makes sense.
Central angle.
Goes through the center.
Perfect.
Next, pick a 3rd point on the circumference of the circle and label this point C.
Okay, so I'll label C here. Okay.
Join A to C with a line and B to C with a line.
Okay, so I'm going from A to C and from B to C. Okay,
Now measure angle ACB.
so from A to C to B. Alright. Okay, let's get out a protractor again. Alright, pretty close there. A little bit off. Okay, this looks to be pretty close to 35 degrees.
Nice. Make sure you record this measurement on your handout as well.
Okay,
This angle you just measured is called an inscribed angle.
okay, so angle ACB is called an inscribed angle.
Vocab alert. So we have a new term here. Make sure you record this on your worksheet in the table for the definitions. Inscribed angle. So, Mrs. H, what is an inscribed angle?
Okay, so if we look at our diagram here then, it's an angle that is formed with 3 points on the circumference of the circle. So we have point A, point C, and point B. All 3 points are on the circumference. And that's an inscribed angle.
Thanks.
Perfect.
Now let's talk about what features central and inscribed angles share. Mrs. H?
Okay, so you're going to want to follow along with Mrs. F, doing the same thing on your example in your workbook as she's doing up on the board here. So start at point A, and we're going to look at the inscribed angle first. So from point A, I want you to trace your finger along a path to point C, back up to point B, and around to A. Alright? Now we're going to look at the central angle. Again, starting at A to point O, the center, back to B, and around back to A. Alright, so along those pathways, what was the one common feature that both the central and the inscribed angle shared?
It was the sharing this arc between A and B on the circle.
Absolutely. That was the only time that your finger traced over the path twice. Okay, so what did we call this arc here?
This is actually called the minor arc
Okay, why is it called a minor arc?
because it encompasses less than half of the circumference of the circle.
Vocab alert, new term. Make sure you get that definition in the chart in your workbook. Perfect. Right, what else should we look at here? So this is a minor arc. Is there such thing as a major arc?
Yeah, it actually is. If you look at on the other side of the A and trace back around to B again, this is what's known as the major arc. So it's the other part of the circle, all around this side, that gets all the way back to B.
And I guess they call it a major arc because it encompasses more than half of the circumference of the circle.
That's right.
Absolutely. Make sure you get that in your vocab chart as well. Perfect.
Another example. Take out your second circle with center marked as O.
Okay, like this.
What is the only example as to where the major and minor arc would be the same?
Okay, well, it kind of makes sense that the only time your major and minor arc would be equal would be when you have a chord that travels through the center, right? So when you have a diameter drawn in. So I'm going to label 2 points here.
Let's label them A and B.
Point A and point B.
Now I want you guys to draw a line that goes through A, O, B.
So from A to O goes to B.
Which makes sure it goes right through the center, which is also known as our diameter.
Right, so what we've drawn is a diameter.
Now pick a point on the outside of the circle, on the circumference, and label this point C.
Okay, I'm going to pick a point right here and call it point C.
Now you need to draw angle ACB.
So I'm going to go for point A. Whoa. Pause.
What is the game?
Okay, try this again. Okay, so after we've picked point C. Okay, so now you're going to...
Now you need to draw angle ACB.
Okay, so we're going to go from A to C, and from C to B.
Let's look at the arcs between points A and B.
Okay, sorry, say again.
Let's look at the arcs between points A and B. We're talking about there's no major and minor arc.
Yeah, but the arc, sorry. But why don't we say, let's just look at the arc that these two angles share in common. So what I've drawn is, okay, we'll pause. So
Yeah, because you're saying between A and B, the arc between A and B though.
Yeah.
No,
Oh,
that's
sorry.
the diameter.
Sorry. This arc, yeah. I'm like, the wording just sounded weird. Okay, say what you're going to say again.
Let's look at the arc between points A and B.
Okay, then, what do you say after that? Still.
Is there a major or minor arc? Because
Okay.
there's not.
But I think you want to point
What's
out...
the shape? Let's talk about what's the shape.
No, I think first of all you want to point out that I've drawn in a central angle and an inscribed angle, and this is the arc they share.
We
You
never
gotta-
talked about that.
Yeah,
so
it's got to
let's
be
do that.
more clear.
Okay.
Okay.
So do you want to go back to draw angle ACB, or are you good with that? Oh, you said pause. Okay, we're
Yeah.
good. Okay.
Okay, so what I'll do is, okay, I've drawn this in, and then I'm just going to clarify that this is my, okay, central and inscribed right now, since I'm here.
Go.
Okay, so what you've had me draw in then is clearly I have a central angle from AOB because it travels through the center, and then I've also drawn in an inscribed angle, ACB. 2 points on the circumference, and the third point, 3 points on the circumference. Try that again.
You have my disease now.
Okay. All right. Okay, so clearly what you've had me draw in is a central and inscribed angle. So the central angle, 2 points on the circumference, the third in the center, right there, and the inscribed angle, points A, C, and B, right, 3 points on the circumference, so the angle formed here. So we've got a central angle and an inscribed angle, and they both share arc AB. Okay, all right, Mrs. F. So what do you notice about the arc shared by this central and inscribed angle?
Well, I noticed that the arc between B and A, and then this arc between B and A are the same. So there's not really any major or minor arc at all.
So what's the special term given for this arc?
Well, to me, if you look and trace along this shape, it actually looks like a semicircle or a half circle.
Right, so this is actually called a semicircle.
Good. Makes sense?
Excellent.
So now we need to measure the angle formed by ACB and AOB.
Okay, so you're asking me to measure my central and inscribed angle. Let's look at the central angle first, AOB. And really, I don't need to use my protractor to measure this because it's a straight line. And we know that a straight line forms an angle of 180 degrees. All right, so this is 180 degrees. All right, so next you want me to measure my inscribed angle, ACB. protractor for that. And using my protractor, it looks like it's about 90 degrees. So angle ACB is 90 degrees. Okay. All right, Mrs. F. Now I think we should probably take a look at the relationship between the measure of the central and inscribed angles in the two examples we've done here. So let's go back one, and we'll take a look at the first example of central and inscribed angles we did, and let's take a look at this.
All right, so noticing patterns here in both of our circles is really important when we're talking about the relationship between central and inscribed angles. And notice that when we talked about our inscribed angle, ACB, it was 35 degrees.
Yeah.
And when we talk about our central angle, AOB, it was 70 degrees. If we do the math, the angle ACB, our inscribed angle, is half of the size of angle AOB, which is our central angle, at 70 degrees.
Okay, so in this example, the inscribed angle is half the central. Okay, so let's take a look at our second example of central and inscribed angles.
Let's still see if that pattern and relationship holds true. In this one, our angle that's inscribed is angle ACB, and the measure of it is 90 degrees. In our central angle AOB, it is 180 degrees. Again, our central is twice that of our inscribed, or our inscribed is half of our central.
I'm detecting a pattern here. All right, so okay, let's put this all together then. We know that the relationship between a central and an inscribed angle is that they share the same arc on the circle. The other thing we know about that, about a central and inscribed angle, is that the measure of a central angle is twice that of an inscribed. Yes?
Perfect.
Perfect.
Yes.
All right, why don't we take that property or those properties and apply them to a practice question now?
Okay, let's look at some examples.
Excellent. All right, so let's take a look at practice question 1 together.
Okay, so it tells us that point O is the center of the circle, and then we want to find out the values of angle X and angle Y here and here. So let's go to the next one and look at it a little closer.
Perfect. All right, so I guess we're going to have to apply some of the properties here that we just learned of central and inscribed angles.
Well, let's look at what we already know. We are told that angle ACB is 55 degrees.
And what kind of angle is that? We've got 3 points on the circumference of a circle. What would you call that?
That would be our inscribed angle.
Okay.
Then we also have angle AOB, which is the one we're looking to find, and that goes through the center of the circle. So what would that be called?
That's our central angle.
So it looks like we have a central and an inscribed angle then.
Right, and they're both sharing the arc AB. All right, so therefore we can apply what we just learned about central and inscribed angles that share the same arc. We know that the central angle is what again?
I think, yeah, we did. We said twice.
Right, so twice the amount of the inscribed. So if the angle here formed by ACB is 55 degrees, that would make angle AOB, which is our central angle, twice that. So 55 degrees, all right, and if we times it by 2, 110 degrees. So AOB, or they've labeled it Y, is 110 degrees.
Perfect.
Okay,
Now that we know that,
let's just put this in here actually. Perfect.
and now that we know these values, it will actually help us find angle ADB. Because let's talk about what angle DB is. Angle ADB, again, has 3 points on the outside of the circle, or on the circumference, which means it's a,
Inscribed angle.
and then we have still angle AOB, which we already identified as a central angle. And so what do we know about an inscribed angle compared to a central angle now?
Well, and the fact that they share arc AB, right, is a must. They have to share the same arc. So since angle ADB, the inscribed angle, and angle AOB, the central, share this same arc, that property between central and inscribed angles holds true again. So if this is 110 degrees, the central, and angle X here, we'll do some blue, oops, is the inscribed, we know that it's half the amount of the central. So what's half of 110?
55.
Okay, so it would be 55 degrees.
And we can label that here.
Perfect.
Good job.
All right, Mrs. F, let's take a look at practice question 2.
Awesome. So we are told again that point O is the center of the circle.
Okay?
Then we label each vertex. That's what we need to do now. So let's label each vertex and give them a name. So we'll label this one A, this one B, and then this one C.
Okay, perfect.
Now it says to determine each value of angle Y and angle Z.
Okay, so this is angle Z in here in this triangle is angle Y. There, so we're asked to find those two angles. Let's take a look at this one a little closer. All right, so what do we already know here? They're telling us that we have a chord, we could call it AEB or BA, that travels through the center of the circle, right? And what do we know about that then?
That means it has to be our diameter,
Right.
and it's also a straight line, which is really important.
Right, so what did we just talk about? Again, it's our central angle. It travels through the center. What do we know about the measure of a straight line?
That it's 180 degrees.
Perfect. And if they're telling us that this angle is 50 and altogether would be 180 degrees, we can solve for angle Z right now. How would we do that?
Well, we just take the full amount of the angle, which is 180 degrees, and subtract what we do know,
The 50.
and that will give us what's left.
Okay. And that's a pretty easy one. Right away, we know that angle Z would be 130 degrees. So let's put that in here. Okay, so now that we've solved for angle Z, we need to solve for angle Y. So what kind of information do we have here?
Well, we do see that there is the radius on this side, and the radius on this side, and the radius on this side, so they're all equal.
Right, and the shape formed here is a triangle with two sides that are equal. What do we call that again?
Isosceles.
An isosceles triangle. And one of the important properties of an isosceles triangle is that the angles formed by the two equal sides, so this angle here and this angle here, would be the same. All right, so if we know that this is 130 and that these two angles are the same, and one of them is the angle we're trying to solve for, Y, it would make sense with knowing that all three angles in a triangle are 180 degrees. If we subtract 130 from that and divide that by 2, we would figure out what angle Y is.
Okay, well, let's do that.
All right, so we're going to take 180 degrees and subtract 130 from it. We're left with?
We're left with 50 degrees,
Okay.
which is 50 degrees, which both of these angles share added together. So if we know that both of these angles must be equal, we would share the 50 degrees over two angles.
Okay, so if we divide 50 in half, we're left with 25 degrees. So we know that this angle is 25 degrees and this angle is 25 degrees. And we can just double check our math here that all three angles together should add up to 180, 25, 25 is 50, 130, that's 180 degrees.
Perfect.
Good job.
You too.
Thank you. Man, that was fun.
It really was fun.
That was awesome. Math rocks. All right. Okay, so let's talk about what we learned in the video today. So the first thing we talked about was a central angle, right? So a central angle is an angle formed by 2 points on the circumference of a circle and the third in the center.
Yeah, and then we talked about inscribed angles, which is an angle formed by 3 points on the circumference of the circle.
Perfect. And I guess the last thing is the relationship between a central and inscribed angle that share the same arc.
And that is, if the central angle and the inscribed angle share the same arc, then the central angle is double the inscribed angle. Or the opposite, where the inscribed angle is half of the central angle if they share the same arc.
Right on. You rock, Mrs. F.
I know, I really do.
Math rocks.
All right. So next video we will be talking about the relationship between inscribed angles.
That share the same arc. Perfect.
It's a trend, really.
And we're one more video closer to possibly having some fun.
Maybe. I wouldn't promise anything to her yet.
All right, we'll see you then.
And bloopers. Have fun. I like that one. I like when you both cheers at the end.
Okay, vocabulary. Okay, so we have a new term here that you're going to want to put down into your vocab chart, an inscribed angle. So, Mrs. F, what is an inscribed angle? Sorry, this is getting ridiculous. We'll start again. Okay, we'll start again. All right, one more time. Woohoo!
I changed my last name. Yeah.
Okay, wait. I wonder if they'll notice I call you Miss and Mrs. throughout the whole video.
They call me that. They shouldn't notice it at all.
Alright, sorry. Okay, here we go. Alright, so vocabulary. We have a new vocab term here, a central angle. So what is a central angle?
Well, central angle literally means an angle that is made at the center. So both of our vertex meets here at the center of the circle, and I totally
Yeah,
lost my train of
that again.
brain.
Okay.
Totally got nervous.
Angle form.
You're in your perfects.
I'm gonna switch it to excellent now.
They make me laugh every time.
I'm gonna be
you do
like,
it. I love it. I love
excellent.
it.
Pause.
Okay. Oh, I guess I should.
All right, vocabulary. So we have another new term here, an inscribed angle. So what is an inscribed angle?
An inscribed angle is where the 3 points on the circumference of the circle. Shoot.
Okay, we'll start that one again.
It's formed by 3 points. I'm like, I just like.
It is just 3 points.